Okay, welcome back everyone to statics. We're gonna do chapter 2 now, and it's gonna be problem 2.2. Okay, it says if the magnitude of R is to be 500 newtons directed along the y-axis, so positive y-axis is gonna go up, the magnitude of force F, determine the magnitude of force F and its direction theta. Okay, so first of all, they're giving us that R in the y direction it's equal to 500 newtons. Okay, so that's something really important we need to know. That means that everything on the x direction of this 700 newtons is going to be cancelled out by the force F of 1. Okay, I'm going to call this little guy F of 2 just to give it a name. So I'm going to start by decomposing F of 2 and into its x and y directions. Okay, so F of 2y it's gonna be equal to 700 multiplied by sine of 15 degrees. And using our calculator, we go 700 sine of 15 degrees, and we get that is 181.7 newtons. Same for its x direction, it's gonna be 700, but instead of a sine, we use cosine. And this will give us 676.1 newtons. Okay, so since we know that F of 1 is going to cancel completely out the x amount going to the left, actually, what we're going to use for the sign conventions, if it's going left, I'm going to do it as negative. If it's going down, we're going to put a negative 2, okay? So let me fix this. Is equal to negative and equals to negative. Okay, now knowing that F of 1 in x direction is going to be completely opposite but same amount, so it's 676.1 going to the right. And how can we find F of 2y? F of 2y, well, since we don't have the angle, what we know is that the resultant, which is the addition of both of them, of the y of 2 and the y of 1, is going to be 500 positive. Basically, what I'm going to do is that the resultant is supposed to be f of 1 y plus f of 2y. But we know this guy, and we also know this guy. So we get 500 newtons on this side. F of 1, y is the one that we want to find. And f of 2y is equal, actually, not to positive, but to negative 181.7 newtons. Okay? So by doing this, we solve for f of 1y, and that will give us the f of 1y, it's gonna be the 500 plus 181.7, which is actually 681.7 newtons going up. Okay, so in order to do the magnitude, what we're gonna do, so I'm gonna put it back in here. In order to do the magnitude, we're gonna apply the Pythagorean theorem, and we're gonna do that the magnitude of force 1, the one that they're asking, is gonna be equal to the square root of 676.1 squared plus 681.7 squared. Using our calculator, we'll find out what that is. So we have to do the square root of 676.1 squared plus 681.7 squared, which will give us 960 newtons. Okay, that's good. Now, how can we find theta? In order to find theta, what we're gonna use is that we know that tangent of theta is equal to opposite over adjacent, which is actually y over x. So if we solve for theta, theta is gonna be equal to the inverse of the tangent of the opposite, which is its y value. So the opposite, 681.7 divided by its x value, which is 676.1. Okay, and by using the calculator, it's gonna be inverse tangent of 681.7 divided by 676.1. That gives us that it is 45 degrees. Okay guys, thank you. That was all for this exercise. We found its magnitude and its direction. See you guys soon. Bye.